Have you ever wondered how your phone, computer, or even your car operates so smoothly? It's like a symphony of circuits and signals, all choreographed by an unseen maestro, the microchip. These tiny powerhouses are everywhere, silently shaping our lives with their intricate designs and complex functions. They're the hidden heroes of our digital age, and yet, they're often overlooked. But understanding their role is crucial to appreciating the technology we use daily. Today, we are diving into the world of microchips, from their humble beginnings to their exciting future. The story of microchips starts in the mid-20th century with the birth of a revolutionary invention, the transistor. This tiny device, capable of amplifying and switching electronic signals, was developed in 1947 by scientists at Bell Laboratories. The transistor laid the foundation for the microchip, replacing the bulky and inefficient vacuum tubes used in computers and radios. As the 50s rolled on, the transistor was miniaturized and improved upon. In 1958, a brilliant engineer named Jack Kilby at Texas Instruments created the first integrated circuit. This was a game-changer. Kilby's design combined multiple transistors onto a single piece of semiconductor material, marking the birth of the microchip. In the following decades, the microchip evolved rapidly, with the number of transistors that could be packed onto a single chip doubling approximately every 2 years. This prediction by Intel co-founder Gordon Moore, now famously known as Moore's Law, has held true for over half a century. The evolution didn't stop there. From Kilby's primitive chip, we moved to silicon chips, then to microprocessors, and now to the complex multi-layered chips we see today. These chips can hold billions of transistors, and are found in everything from our smartphones and computers to our cars and kitchen appliances. This was just the beginning of what would become a revolution in technology. So what makes these microchips tick, you might ask? Well, let's break it down. At the heart of a microchip are millions, sometimes billions, of transistors. These tiny switches control the flow of electricity, turning it on and off. Now, imagine these transistors as a vast city of light switches, each one contributing to a grand design. When a current is applied, the transistors open and close in specific patterns, creating binary code. That's ones and zeros to you and me. This binary code is then translated into the actions and processes we see on our devices. The magic really happens when these transistors work together in circuits, each performing a specific task. Some circuits form the chip's memory, others handle calculations, and others manage input and output. It's a symphony of electrical signals, all orchestrated to deliver the power and functionality we've come to expect from our devices. These tiny powerhouses are the heart of our electronic devices. It's hard to imagine a world without microchips. We live in an era where these tiny silicon wonders are embedded in almost everything we interact with daily. They're in our smartphones, powering our ability to connect, communicate, and consume content at an unprecedented pace. They're in our computers, enabling us to work, create, and explore digital realms. But it doesn't stop there. Microchips are in our cars, enhancing safety with features like anti-lock braking systems and advanced driver assistance systems. They're in our home appliances too, transforming ordinary household items into smart devices. Your refrigerator can tell you when you're out of milk, your washing machine can adjust its cycle based on the weight of your laundry, and your thermostat can learn your habits to optimize temperature and save energy. Microchips are even found in our credit cards, passports, and pet collars, adding layers of security, convenience, and peace of mind. Microchips have truly become an integral part of our daily lives. What does the future hold for microchips? As we peer into the crystal ball of technology, several intriguing possibilities emerge. Imagine microchips evolving into even more efficient designs, each iteration smaller yet more powerful than the last. With relentless advancements, we're likely to see a surge in processing power that will drive innovations beyond our wildest imaginations. Consider the emerging field of quantum computing. Here, quantum microchips could potentially solve complex problems at speeds that dwarf today's fastest supercomputers. Or, picture microchips designed for specific tasks, like those tailored to propel artificial intelligence or to revolutionize medical diagnostics. Perhaps we'll see microchips embedded in everyday objects, further fueling the Internet of Things. Imagine your coffee mug, advising you on the perfect brewing temperature, or a plant pot that tells you when your fern needs watering. While we can't predict the future, one thing is clear: microchips will continue to play a major role in technological innovation. Like any technology, microchips come with their own set of challenges. Now let's delve into some of these issues, starting with energy consumption. As our demand for smaller, faster, and more efficient devices grows, so does the need for microchips that can meet these requirements. However, this increased performance often comes at the cost of higher energy consumption. This is a significant challenge for microchip manufacturers who must continually innovate to balance power and performance. Next up, let's talk about security. In our interconnected world, microchips are in virtually everything, from our smartphones to our cars, even our fridges. This ubiquity makes them a prime target for cyber threats. Hackers can exploit vulnerabilities in microchips to gain unauthorized access or disrupt the operation of devices. Therefore, manufacturers must design microchips with robust security features to protect against these threats. But it's not just about guarding against cyber attacks. The physical security of the microchips themselves is also crucial. Microchips can be damaged or destroyed by factors such as heat, humidity, and physical shock. This is a particular concern for microchips used in harsh environments, such as those in aerospace or automotive applications. Manufacturers need to ensure that their microchips can withstand these conditions without failing. Now let's move on to the environmental impact. Microchip manufacturing involves numerous chemicals and produces a significant amount of waste. Additionally, disposing of old microchips can be problematic, as they often contain hazardous materials. Manufacturers need to adopt more sustainable practices, such as using less harmful chemicals and implementing recycling programs, to lessen the environmental footprint of microchip production and disposal. Lastly, there is the issue of resource scarcity. Many of the materials used in microchips, such as rare earth metals, are finite and could become scarce in the future. This poses a potential challenge for the continued production of microchips and highlights the importance of developing alternative materials and recycling methods. Addressing these challenges is key to ensuring the sustainable and secure use of microchip technology. By acknowledging and tackling these issues, we can continue to enjoy the benefits of microchips, from our smartphones to the Internet of Things, while minimizing their potential drawbacks. Microchips have come a long way since their invention. From their humble beginnings as silicon slivers, these technological marvels have evolved into an integral part of our daily lives. They've shrunk in size, but expanded in capability. They've powered the rise of the digital age, enabling the creation of the computers, smartphones, and other devices we rely on every day. The history of microchips is a testament to human ingenuity. From the first transistor-based devices to the complex processors of today, each step in their evolution has brought new possibilities. They've made our world smaller, our communication faster, and our lives easier. In terms of their function, microchips are a marvel of engineering. They process information, control systems, and store data, all while being small enough to fit on the tip of your finger. They're the heart of our electronic devices, silently working behind the scenes to make our technology run smoothly. Looking towards the future, the potential of microchips is vast. They're set to drive the next wave of technological innovation, from artificial intelligence to the Internet of Things to entirely new computing architectures. But with this potential comes challenges. Power consumption, security, and environmental impact are all issues that need to be addressed as we continue to rely on these tiny powerhouses. But perhaps the most important challenge we face is education. As microchips become more complex and more ubiquitous, it's crucial that we understand how they work and the impact they have on our world. After all, they're not just pieces of silicon, they're the building blocks of our digital future. As we continue to rely on these tiny powerhouses, understanding their workings and impact becomes increasingly important. Remember, the next time you use your phone or turn on your car, you have a microchip to thank for it.